Hi, I'm Paul. This is Science That Sticks. It's November the 5th, bonfire night in the UK. And behind me is my garden. Down there is, where the Science That Sticks board is and where I do some of the calculations. It looks like it's floating. It's just dark. Anyway, that aside, today is November the 5th. That's bonfire night. And as part of the celebrations, memorial, whatever you want to call it, festivities probably is a better description for this. We let off fireworks, and there's an awful lot of them going up into the sky behind me. Why is this to do with science? Well, it's to do with a question that shows up for GCSE students and for Key Stage 3 students. It's to do with the speed of sound. Specifically, speed is equal to the distance divided by the time of something. Okay, fair enough, who cares? Well, when you're enjoying fireworks, no one cares. But when you're sitting an exam, there's normally some sort of question. Gotcha. We can actually time how long that took for that firework to come up. We saw the light, then we heard the explosion. Now, if we didn't hear it this time, we will certainly see some footage in a moment because I'll take my mic off. Now, the idea is that you're given the speed of sound, you're given the time taken for the explosion to go from there to here. Now, there's other questions associated with this. The first of which is, why were you able to see the explosion before you heard the explosion? Obviously, light travels faster than sound. Cool, no problem. Then it asks you quite often to calculate how long it actually takes for the sound wave to reach you. So you've got to rearrange the equation. Let's see if we can get something on video and so that you can hear it. So I'm going to turn the mic off and I'm going to do some filming. Okay? So how far away were some of the fireworks from where I was? And the answer to that is simple. It needs to be calculated. I need to know the speed of sound in air. Okay, I don't know that, but I can look that up. So I did. Turns out the speed of sound in air happens to be 330 meters per second. Fair enough. Now, I need a time. That means I have to record the time from when I see the firework explode to the time I actually hear the explosion. And it's not that easy. Well, at least it shouldn't be. In this day and age, we have smartphones. Thank you, Apple. Now, I've used my iPhone and I've filmed some of those fireworks going off. And I've managed to get one, which was very far in the distance. And you can see it now. That took a little bit of editing from my point, and I've got it down to about 2.1 seconds. That's from the moment I see the light in the distance of the explosion and when I hear the actual explosion. So it's 2.1 seconds. Now, how do I find the D? How do I find the distance? Well, the answer to that is I've got to rearrange the speed equation or the velocity equation. So the speed is equal to the distance divided by the time. A lot of science teachers like using the triangle, and for the sake of ease and brevity, I'm going to put it like this. Okay, so that's speed times time is equal to distance. Distance divided by time is equal to speed. Distance divided by speed is equal to time. I need distance, so these two get multiplied together. And it turns out that when you multiply 330 by 2.1, you get 693 meters. So the firework that you just saw happened to be 693 meters away from me. Easy peasy. That's it for the speed of sound and with fireworks. Let's see what else we can learn about fireworks then. Check out the other videos.